measure of y with respect to x. So that's all that you need to remember. Starting with the first question, find the rate of change of the area of a circle with respect to its radius when the radius is 6 centimeters. The area of a circle is pi r squared. You have to find the rate of change of the area with respect to the radius. So dA by dr will be 2 pi r, and then you calculate dA by dr at r equal to 6, which is 12 pi centimeters squared per centimeter. Let's go to the next question. If the radius of the circle is increasing at the rate of 0.7 centimeter per second, at what rate is its circumference increasing? Now circumference is given by 2 pi r, and you have to find the rate at which the circumference is increasing. So I will calculate dc by dt. That will be 2 pi r dr by dt. dr by dt is 0.7, so this is 2 pi into 0.7, which is 1.4 pi centimeter per second. Coming to the next question, if the sides of a square are decreasing at the rate of 1.5 centimeter per second, at what rate is its perimeter decreasing? Now, if x is the side of a square, perimeter is given by 4x. So dp by dt is 4 dx by dt. And the sides are decreasing at the rate of 1.5 centimeter per second. So this will be 4 into minus 1.5, that is minus 6. So perimeter is decreasing at the rate of 6 centimeter per second. Coming to the next question, if the sides of a square are decreasing at the rate of 1.5 centimeter per second, at what rate is its area decreasing when its side is 8 centimeters? So area of a square is a squared. We calculate dA by dt. Using chain rule, it is 2a dA by dt, and the sides are decreasing at the rate of 1.5 centimeter per second. So dA by dt will be minus 1.5. And now the side is 8. So if a is the side and substituting a equal to 8, we get minus 24 centimeters squared per second. Now coming to the next question, find the rate of change of the volume of a cube with respect to its edge when the edge is 5 centimeters. So volume is x cubed for a cube if x is the side. So we have to find the rate of change of volume with respect to the edge. So dv by dx is 3x squared, and we want to find dv by dx at x equal to 5. So it is 75 centimeter cube per centimeter. Coming to the next question, a balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with respect to its radius when the radius is 10 centimeters. So volume of a sphere, a balloon which remains spherical. So we are looking at volume of a sphere, that is 4 by 3 pi r cubed, and we have to find the rate at which the volume is increasing with respect to its radius. So dv by dr will be 4 by 3 pi 3 r squared, and then you put dv by dr at r equal to 10, so you get 400 pi centimeter cube per centimeter. Moving to the next question, if the radius of a balloon, if the radius of a balloon which always remains spherical is increasing at the rate of 1.5 centimeter per second. At what rate is its surface area increasing when the radius is 12 centimeters. So for a sphere, we are looking at the surface area. So surface area of a sphere is 4 pi r squared. So we calculate dA by dt, that will be 8 pi r dr by dt, and the radius is increasing at the rate of 1.5 centimeter per second. So dr by dt is 1.5, and then you substitute dA by dt at r equal to 12. You will get it as 144 centimeter squared per second. Okay, let's go to the next question, and that is a cylindrical tank of radius 10 meter is being filled with wheat at the rate of 314 cubic meter per hour. Find the rate at which the depth of the wheat is increasing. So we take pi as 3.14 in this case. So let's start. Now radius of the area of the volume of a cylinder. The cylinder is being filled with wheat. Volume of a cylinder is pi r squared h. The radius is 10 meters, so it becomes pi 10 squared into height. And you want to find the rate at which the depth of the wheat is increasing, basically dH by dt. So differentiate with respect to t. So dV by dt will be 100 pi dH by dt. Now dV by dt is 314 because it is being filled with wheat at the rate of 314 cubic meter per hour. So dV by dt is 314. This is 100 pi dH by dt. And then you put pi as 3.14. So when you simplify, you will get dH by dt as 1. Let's move to the next question. Find the rate of change of the whole surface of a closed circular cylinder of radius r and height h with respect to its radius. So this is question 12. So we have to find the rate of change of the whole surface area. What is the formula for the whole surface area of a cylinder? 2 pi rh plus 2 pi r squared. We have to find the rate of change. So you have to calculate the rate of change with respect to the radius. So dA by dr will be 2 pi h plus 4 pi r. So that concludes this first session on applications of derivatives, rate of change.